please, a round of applause for our members of the Scientist Coalition in the panel. We will introduce them, but let's have them join me on the stage, and let's give them a round of applause. And we are going to meet them now. So first we have Tara Olsen. Tara Olsen is a research assistant at the Lund University in Sweden. Her background is environmental law and policy. And so let's get a round of applause for Tara. Next on the panel we have Martin Wagner, biology professor at the Norwegian University of Science and Technology. Martin. Next we have Natalia Grilli, PhD candidate in political science at the University of Tasmania, and her research background is in biology. As well, we have Rufino Varea, PhD candidate in marine science at the University of the South Pacific, with a research background in ecotoxicology. So we're going to begin with Tara Olsen. Tara, before you begin, I wanted to ask you, why did you join the Scientists Coalition?
Well, having a legal background, I thought it would be very beneficial and important to get an understanding and overview of the multidisciplinarity that is within plastic pollution. And if you're implementing laws and policy, you need that science understanding, which my education did not give me. And it has then been very beneficial, and I've learned a lot within the Scientist Coalition on the science behind plastic and the science that is needed to implement effective policies and laws within this treaty.
Okay. Well then, I would love for you to just go right into your talk right now.
Yeah.
Yes.
Perfect. So I will talk about our first key message, which is about the need for reduction. There's an urgent need to address upstream measures within this treaty. And it is because we need to address the root cause of plastic pollution. The plastic pollution crisis will not be able can only ever be addressed efficiently if member states collectively commit to reduce production of primary plastic polymers, PPPs. And you must ask yourself why. Well, plastic production has doubled between the years 2000 and 2019, with 460 million tons being produced in 2019 alone, according to OECD reports. And there's a cumulative production reaching 10 million tons in 2020. There's also a growing body of evidence, of scientific evidence, on the harmful impacts of plastics and plastic pollution on humans, on environmental health, on sensitive species and ecosystems, and climate. At the current production rates, we can already attribute more than 5% of greenhouse gas emissions to plastic production. Even if plastic production would be reduced between the ranges of 1% to 3% per year, the global plastic pollution would continue an upward trend, and cumulative production would reach at least 20 million metric tons of plastic by 2040. So we would double it again. In light of all of this, the Scientific Coalition calls for an ambitious global reduction target for PPPs that includes national phase-down schedules and global aggregate targets in order to reduce overall production of PPPs. However, we face one massive challenge with this to implement this, and that is the lack of production data transparency. This includes disclosure of polymer types and chemical contents. There's an urgent need to ensure that primary plastic polymer production and consumption data is made available, as this information is essential in order to establish baselines and targets, as well as effective reporting and monitoring schemes. Integrated sustainability, safety, essentiality, and transparency assessments can effectively guide development and implementation of these reduction targets. Learning from other MEAs, we stress the importance of global targets instead of nationally determined ones, like in the Paris agreements, because these have been shown to be ineffective. We need to root action in multi-stakeholder processes grounded in robust, evidence-based, and conflict of interest-free policy, supported by transparent monitoring, reporting, and assessment processes based on 5 key reduction pathways. And these are: first, to reduce non-essential use; 2, to reduce unsafe and unsustainable use; 3, to increase transparency and responsibility throughout value chains and life cycles; 4, to improve and implement compliance mechanisms; and 5, to be inspired by sectoral precedents. To conclude, we would urge member states to support a globally binding PPP reduction target, supported by mandatory PPP reduction targets, to reduce the complexity and the overall global volume of plastics being produced.
Thank you, thank you. And you're saying PPP a lot, and what was PPP again, just for me, because I don't know what PPP is.
It's primary plastic polymers.
Primary plastic polymers, and that's bad?
It's how we define.
Oh, it's how plastic is defined.
Yes.
Okay, and then you were talking about these global targets rather than the national targets. Why are the national targets ineffective?
Well, it was a new approach in the Paris Agreement that was adopted in 2015 for climate change.
Yeah.
And the idea was that each country could determine, based on their national capabilities, what their targets and reductions should be. But we have just seen that these levels have not been high enough to actually address and try to reach the 1.5 climate targets that we have. And it's been, we just had a global stocktake last year, which showed that, last year was one of the warmest years on Earth.
Yeah.
So we have to learn from this. And one of the other MEAs that have been deemed very effective has been the Montreal Protocol, and that used global targets.
Global targets. Global targets are better.
Apparently so.
Apparently. Okay, well, let's go for some global targets then. Thank you, Tara. And you can pass the mic down to Martin Wagner. Now, Martin, you are a biology professor, and I want to ask, why biology? What brought you to biology?
That's a good question, and I don't really want to give you my life story, but I can say it's a lot of coincidence involved that I
Well,
became...
we would love to hear some of your life story, a little bit of your
Nobody
life
wants to hear
story,
that.
Martin.
But there's a lot of coincidence involved, of course, in becoming a scientist. But I can share one story, and that is that when I graduated high school, I was really set on a very different path. You know, I'm coming from a family where I was the first to go to university. So my parents took me aside and said, like, you need to learn some proper job and get some proper education. So become an engineer. So I studied electrical engineering, and it was a disaster. So I dropped out, and then, you know, because I was always kind of in love with nature, always out in the woods, playing there, etc., I thought, let's try biology. Yeah. And I loved it ever since.
And you've been a success.
Well,
are your parents proud?
They are.
Good. Martin, I would love for you to go right into your key messaging here.
Right, so I'm going to speak to safety criteria and safety aspects of the treaty, which is one of the priorities that the Scientists Coalition has identified. And before I'm going to talk a bit about the details of our thinking there, I want to circle back a bit to the beginning of the whole process and to the beginning of the UNEA Resolution. And I really want to say that at the heart of the UNEA Resolution and the INC and the future treaty is the idea to create a healthier relationship with plastics. And that means a healthier relationship of humans, of society, with those materials, but also a healthier relationship for our environment. And I think it's a very powerful vision that the treaty can bring across in creating such a healthier relationship with plastics, because the science is telling us that our relationship with those materials is not healthy at all at the moment, right? So the science tells us that there's thousands of chemicals in plastics, many of which we know are hazardous to the environment and our own health. And I could talk for hours about endocrine disrupting chemicals. We know about their substantial health effects. We know about the substantial costs that society is bearing for dealing with the consequences of exposure to these plastic chemicals. But I rather want to give you a local example from the environment. So for instance, there's one chemical that is being used to make car tires. And that chemical, 6-PPD it's called, is not staying in the car tires. It's leaching to the roads. It's leaching from the car tire particles that we're emitting to nature. And that chemical is very toxic to salmon species. For instance, the coho salmon, that's like native to the North Pacific, native to Alaska, to the western regions of Canada. And it's very toxic to those salmon species, to those beautiful fish. And it actually leads to mass die-offs of those salmon. So that's an example where we see like very specific and substantial impacts of plastics on ecosystems as well. But it's not only the chemicals that are a concern, it's really also the particles that are shedding from the plastics we're using on a daily basis. And I think it's almost a truism if I tell you that we find nanoplastics and microplastics everywhere on a global scale. It's a ubiquitous pollutant. And you know, it's a truism, and it's kind of sad that people just say, yeah, plastic pollution is everywhere. And I want us to think for a second about what that really means. Within 50 years, we have managed to contaminate the planet with those plastic materials. And while we know that plastic, microplastics, nanoplastic, plastic pollution is everywhere, new science is emerging on a daily basis looking into the adverse effects of those materials, of those particles. And I know that there's like a notion out there that nano and microplastics aren't very toxic, they aren't very problematic. But if you look at the latest science, there's studies being published on a daily basis, as I said. And if you do meta-analysis of those studies, you will see that very sensitive organisms, very sensitive species, actually are being affected by very low concentrations of microplastics. For aquatic ecosystem, that level is at about 3 particles per liter, and that's like levels that we're seeing quite widely now in the environment. So the science is telling us that we're having an issue in our relationship with plastics, but delegates might wonder, how can a treaty bring across a healthier relationship to those materials? So as a scientist coalition, we argue for implementing safety criteria across the full life cycle of those plastics, starting from feedstocks, starting with the chemicals that we are using to make those materials, and then moving to products, services, and technologies. And these safety criteria sound kind of complicated, but actually they're quite common sense, For instance, we argued that we should not allow hazardous chemicals to be present in our plastic. And that means simply we don't want chemicals that can cause cancer in our plastic products. We don't want chemicals that are very persistent and stay in the environment for hundreds of years in our plastic products. So that's one aspect of those safety assessments. And it might sound kind of complicated to implement all of these, but I want delegates to remember that at the core of the treaty is that vision of creating a healthier society. So if we manage to implement safety criteria, which are the prerequisite for everything else that we're trying to achieve, sustainability, circularity, just transition, we need to get the safety aspects right in the treaty. Thanks.
Yes. Can I get a round of applause for Martin? And Martin, you said a couple things that it makes me ask. You were talking about microplastics and nanoplastics. That's just very small, little pieces. And everywhere. You're saying they're everywhere.
Yeah, right.
Like inside me.
Well, the latest science, and I must say I'm quite surprised by really the latest science on nano and microplastic shows that we have these particles in our bodies. And
So
if
I right now, I have microplastics inside me.
if you would donate a blood sample, we could check, but
Okay.
you probably don't want to do that today.
Yes, I will donate my blood today, Martin, to you, so that you can test my blood.
But no,
It's probably.
it's possible, and the science is emergent, and I can just say about 5 or 6 years ago, when somebody had told me that micro nanoplastics would end up in people,
Yeah.
I would have said it's very unlikely. If I read the
Wow.
latest science, I would say it's very probable.
And how do I get it out? How do I get that out of me? How do I take it out of me, Martin? Now everyone's listening. You have microplastics in you right now, maybe. We're taking blood samples after the panel.
Let's not do that.
How do we take it out of us, Martin?
Well, first of all, we really don't understand like how long plastic is sticking in our body, whether we excrete it or not, whether we have
Oh.
mechanisms to get rid of it. So that's something that needs to be researched better.
Okay.
But the obvious call is to avoid us being exposed to these particles.
Well-
So one idea, obviously, for the treaty would be to emphasize design criteria that minimize the release of nano and microplastics from the products that we're using on a daily basis so that we can reduce exposures.
Yeah. Yes, please. I don't want it in me, and I don't want it in you either. Thank you, Martin. A round of applause for Martin.
Thanks.
Whoa. Next, you're passing the mic to Natalia. And I will do a Q&A after everyone has spoken. I will open the floor to everybody. Natalia, now it says, you told me that your research background is in biology. So why did you make the shift from biology to the political science?
Can you hear me? Yeah.
Everyone can hear Natalia?
So I'm a biologist by training, and around 10 years ago, I started researching environmental management and working more closely with policy and decision makers. And I just became more and more interested to understand this space in the science policy interface and how it is a two-way road. How science become public policies, how like bad news become public policies, as our ambassador said, and how working more closely with policymakers helps us, like as researchers, come with better research questions. And just to illustrate that with a little story, I was in Barcelona 2 weeks ago to the Ocean Conference, Ocean Decade Conference, and the Executive Secretariat of the Intergovernmental Oceanographic Commission, in his opening speech, he said something that caught my attention. He said, for those ones who are not familiar, the theme of the Ocean Decade is the science we need for the ocean we want. And he said that the science we need is absolutely fundamental to the ocean we want, but it not takes us there automatically. There is this space between that needs to take science into account to build partnerships, to get funding, and to build policy action. And I think this is also true for the plastics treaty, and that's what we're doing here, and that's what I'm passionate about.
Yes, and I think it's important. Yes, thank you. I would love to hear what you have to say.
Yeah. I'm going to talk a little bit about the sustainability criteria, as Tricia already mentioned briefly. We think that it's absolutely important to adopt distinct sustainable criteria to assess plastic chemicals, polymers, products, materials, as well as alternatives, substitutes, and new technologies. But we see in the revised zero draft the word sustainable or sustainability several times, but what does it mean actually? So just want to highlight that we understand sustainability as used in the UN Brundtland Commission and in other multilateral environmental agreements which means to consider different dimensions such as environmental, social, cultural, and economical in a balanced manner. And according to resource consumption, such as water, energy, land use, and carbon and other substances. And this is really important because using this criteria will help us to support the production and consumption reduction. Like, for example, if we have sustainability criteria to design more sustainable products, we can have design for simplification, for durability, for reuse, repairability. So if you have products that last more, for example, we don't need to consume as much as we do today, so it will help us reduce in that sense. And if we had more products that consider cultural values and social values and economic and environmental issues, we help to promote more integrated and holistic views and solutions, avoiding regrettable solutions and single-use one, and helped us to consider the full life cycle of plastics. And finally, helps us to innovate and find a future and a circular economy that is non-toxic, and consider the waste hierarchy, which is invest our efforts first in reduction and less in the waste management as it is today.
Okay, thank you. Thank you, Natalia. And you mentioned the possibility of alternatives. What are some of those alternatives? What I think is maybe something that is not fossil fuel based. Is that like a bio, or I'm not a scientist. I think I mentioned that.
Yeah, that could be one of the possibilities,
Okay.
because right now more than 90% of our plastics are oil-based.
Right.
So one of the alternatives could be another technologies and other materials, as we actually have a fact sheet on bio-based plastics, which I recommend you to read. But yeah, that's one of the possibilities.
And are you a fan of the bioplastics as an alternative?
I think it depends because not only the source needs to be assessed, we need to assess all the other elements to avoid regrettable solutions. For example, if we need to deforest a native forest to plant something to build, plastics is not good as well. So that's the importance of having the sustainability criteria.
Yeah, looking at the whole picture. Look at me trying to find an easy solution, and there is no easy solution. Thank you, Natalia. And yes, now we pass the mic to Rufino. Rufino, it says, you told me that you're a PhD candidate in marine science, and what has brought you to marine science? What was it about the science of marine that really made you excited?
First, I'll just start off by saying Bula, Bula everybody, hello, hello, Bula. So just to answer that question, well, I am from the Pacific Islands, and we are covered by vast ocean space. We are connected by the ocean, and most of our, culturally speaking, most of our origin stories are that, you know, our islands emerged out of the ocean. And one of the things I've come to value a lot is that we can only protect what we know. And coming from the Pacific, it just makes sense to move into a field like marine science to learn more so that we can protect, yes, our
It makes a
people
lot
and
of sense, Rufino. It makes a lot of sense.
Thank you.
I wasn't questioning you. I was curious. Rufino, I would love to hear what you have to say.
Thank you so much. So I want to first thank my fellow colleagues, panelists, for covering that everything that they've just covered. And I'm going to delve a bit more into the traditional knowledge side of things. And if I can just take a moment of your time, I hope that you will see and come to appreciate more, a little bit more, indigenous knowledge systems and values. Some of these examples that I'll be giving is from the Pacific. Actually, it's all from the Pacific. And here's just a few demonstration of how impressive indigenous knowledge systems, well, I found it to be very impressive. So the people of Nduandua Island in Fiji, they can actually interpret breaking waves. They can interpret breaking waves to predict a cyclone up to 1 month before it hits. And in the Torres Islands in Vanuatu, there are 13 phrases to describe the state of the tide. And such observations make scientific sense because distant storms drive ocean swells onto coasts long before the winds and the rains arrive, which changes these usual tidal patterns. And the people of Vanuatu, they interpret a halo around the moon as a signal of coming rainfall. And based on scientific observations, we know that clouds contain ice crystals, which moonlight filters. And it creates that halo effect. So again, this makes sense. And then across the Pacific, people can predict the coming of wet weather simply by observing the central shoot of the plantain, which would be curled instead of being straight. And this is explained scientifically by a process in which plant leaves close in order to protect their reproductive system during extreme weather events. And this is just a few of many examples of just how remarkable indigenous knowledge systems are. In the university that I am in, there was a researcher who was looking into the possibility of culturing an endemic species of fish, locally known as reve. And what he wanted to do was to try and close the life cycle of the fish so that they could breed it in aquaculture for a food security program. But the problem was that there was very little literature of this endemic fish. They didn't know much about it, but he needed to close that life cycle in order for this aquaculture program initiative to work. And so instead of racking his brains, what he did was he approached an indigenous community who actually uses, this fish is a cultural totem for them. And what they did was they exchanged all this, they transferred all this traditional indigenous knowledge to this researcher, and he managed to close the life cycle of this endemic fish, which they can now, instead of harvesting the wild stock and threatening its existence, they can now breed it through aquaculture for food security. And this is just, it just highlights how remarkable, how important traditional ecological knowledge is in this space, in this process. Yeah?
Absolutely.
And as I said earlier, we can only protect what we know. And it is true to say that climate change has put indigenous ecological knowledge to the test. And we fear that what we know may not be enough to sustain us, to protect us, to keep our ways alive. But as a threat multiplier to the triple planetary crisis, plastics and its chemical additives is an absolute insult to nature and people, and on indigenous knowledge systems and worldviews. In my research, indigenous communities have noted the disappearance of sacred totemic fish and the desecration of indigenous ecosystems by plastic pollution. You know, plastics is not part of nature. And from an indigenous perspective, there should be no place for plastics. But what the Scientist Coalition is pushing for and supporting in these negotiations, they are necessary. And as respectfully as I can admit here with you all, these priorities are the uppermost limits that indigenous peoples and our communities can cope with for our survival. And I feel honored to be working alongside you all and also learning from you. So thank you. Yes. Naka.
Thank you, Rufino. You mentioned a number of things that made my jaw drop. The first one was the wave breaks in Fiji. Involuntarily, my mouth opened wide. A month later, based on the observation of the wave breaks.
Yes, it's very impressive, and these are observations that have improved and perfected over many generations,
Yes.
and passed down.
Yes.
So yes,
We have to listen more, much more.
yes.
I want my jaw to drop more. Rufino, I think we're going to talk more because I'm sure you have more to tell me and to tell everybody about all of these observations. Thank you.
You're
Thank you,
welcome.
Rufino.
Thank you.
So I would like to open the floor up to a short Q&A. I believe we do have some people that are going to grab a microphone. If there is someone, we're doing a Q&A. Just so you know, Q stands for question, and the A, it stands for answer. So you will ask the Q, and we will have the A. So if somebody has a Q, you could maybe raise your hand. I see a Q over here, but first there's one over here. There's a Q over here. We're just going to make sure that the microphone is on. Yes.
Yeah. Thanks. Thanks a lot for this space and for inviting us all, for making it very open for everyone. My question goes to Rufino. It's wonderful to meet you, and we had the pleasure to have a conversation with you a couple of weeks ago. It's a real honor to get to know you more. We are here from the Galapagos Conservation Trust. My name is Lucia Norris. I'm from Ecuador, and we are focusing in Galapagos and supporting Galapagos in conservation and sustainable development. We have been doing 5 years of science to understand sources of plastic pollution and the impacts in the environment and society and our livelihoods there. But we are really keen to know more about how to include indigenous knowledge systems in this network that we have in the region called Pacific Plastic Science to Solutions. So my question, Rufino, is can you enlighten us a little bit and share a couple of tips of how to include these indigenous knowledge systems on our network? We really would love to know a little bit more of that.
Thank you. That's an amazing question. I'm not quite sure if I'm the right person to give the answer for it, but I will say that these processes, as complicated as it can be, if you want to include or embed indigenous knowledge systems, it would be ideal to. For the Pacific, you'd have to approach the PSIDS, the Pacific SIDS leaders about that, because that would be a more political action required. But if there are indigenous values within the knowledge system that you wish to incorporate, I can connect you with the right people to do that. Yeah, even though I may not have the answer, but I know people who will have the answer for you.
Okay, thank you. I think there was a question over here.
Thank you. I have to figure out the distance here. Very interesting panel. My name is Ronald Steenblick from the Quaker United Nations office. And my question is addressed to anybody who would care to answer. We've heard a lot about the interest of the Scientists Coalition in basically restraining production. But I wonder if you would agree that one of the basic ways of addressing the growth in production is to stop the subsidies that feed that growth. This is what we're concentrating on, is trying to get in language in the treaty on constraining subsidies to primary plastic production.
Hello. Thank you for your question. I think eliminating subsidies for fossil fuels is one of the measures that can be implemented upstream, and definitely needs to be addressed within this treaty. And there's a few countries that are pushing for it as well. But I think it's important to have a wide range of measures. So eliminating subsidies can be one of them, but we should also include other supply side measures within that.
I apologize to come back, but I really need to make this clear. There are people who are saying we need to get rid of fossil fuel subsidies. Nobody disagrees with that. But in the context of the treaty, that would be way, way, way too big of an ask. What we're talking about is those part of subsidies that are very specific to plastic production. So that would be low-cost energy to polymerization plants. That would be low-cost feedstocks, subsidized feedstocks. It would be subsidized capital for building those. So that distinction in terms of the which terms we're using is very important, because we've already heard from some countries that that they think that we're talking about trying to eliminate all fossil fuel subsidies, which is a much bigger ask and something which is being dealt with in other processes.
I think that we can agree with what you're saying. Yeah, absolutely. Do we have another? I see a couple hands over here.
Not just the subsidies, but do you think that stricter restrictions on how they utilize plastics and how the waste management of it is needed? Because they're doing it to everybody else that talks about it. They increase, the felonies and everything for us, but they maintain having the money, and that's part of it, and that's part of the welfare that goes to the corporations.
So that question would be about.
Sorry, I didn't hear you properly. Just restrict production.
Restrict production entirely.
That's yes. Yes, we would want to have global reduction targets, and that would include reducing or banning certain non-essential plastics, like single-use plastics, and that could be a blanket ban if countries agree to it.
Haku, so my question for Rufino, or maybe the maybe the whole Scientist Coalition, when I hear about embedding indigenous knowledge in science, my concerns that I hear is what discussions have been had to protect that indigenous knowledge when talking about upscaling on a global level, and how do we protect it from getting misused, abused, and commodified to a point where it's become extractive and it's become harmful to where that indigenous knowledge and the indigenous science is coming from.
I don't know what the answer to that would be. Rufino, do you
want to take it? No. I would just a comment on that. We just released a policy brief today about the science policy, the science policy interface instrument. How do I say, like the group? Yeah, that will help the implementation of the treaty, and that should be inclusive with indigenous science as well. So it's a matter of include the indigenous scientists and knowledge holders into this body so that they can also take into account, and this process can be very representative as well, like seriously representative.
Thank you. And just to add on to that, I think it's really important and good that we have a coalition of over 300 scientists who have, collectively agreed to ally with and support indigenous peoples' inclusion, and echo their concerns and their needs, and find the best and most respectful way to produce materials and resources that can encourage others to also, join this movement that support. Thank you.
Okay. Can I get a round of applause for the panel as well? I would